Welcome to the GESDA Summit interview series. With us, Chiara Bartolozzi, a tenured senior researcher at the Italian Institute of Technology, and you are working towards the design of autonomous machines, and you participated in the session today called Embodied Neuromorphic Intelligence. Can you tell us a little bit more about your work? What are autonomous machines exactly?
So we can start from the autonomous machines, that is machines or agents that can autonomously go around in our world and accomplish a task. So you can think of a robot that enters a room and, cooks a meal, or a robot that goes in the field, look at if there's any pollution or if there's a need to water the plants and deliver waters to the plants that need it and doesn't waste water all over the place. How I do that is really basic science. That is, we look how our brains work and try to reproduce circuits like hardware that can go inside the robots and give the robots an intelligence that is similar to our intelligence. That is, entering a room and understanding what is around and the space, the objects, the people, and so plan for its actions to achieve a certain goal.
So neuromorphic intelligence, what does that involve exactly?
It really involves looking at how computation is performed in the brain and is performed through sensors that are more similar to the sensors that we have rather than camera that we use for TV, and developing a technology that works with similar principles. That is, instead of using the transistors, the elements that are inside our computers as they are used now, using them in a way that can work more similarly to our brain.
But you are not using actual brain matter, you are just copying brain matter.
We are not using brain matter, we use hard electronics, or we use new materials to capture the computational principles. We don't like saying we copy because copying is not something useful to do because the materials are very different. We don't use cells, we don't use neurons, but we use electronic circuits that somehow capture some of the behaviors of the neurons, those that we think are useful for computation.
So how far can you go with this technology? Are you going to replace humans?
No. No, the idea is to replace power-hungry computation elements that we have in our current technology with computational elements that, being more similar to the brain, also have the same capabilities. That means, for example, as we said, understanding, right? You enter a scene and you understand that you have a person in front and you understand how this person is moving, and doing so with lower computational resources and lower power resources. This doesn't mean that we will have, replacements.
You're improving our lives.
We try.
Thank you very much for talking with us today, Chiara Bartolozzi. Thank you.
Thanks a lot.